Okay, so when you build an AI model, what you're really doing is creating this incredibly complex machine, a machine that's designed to learn. But here's the thing, just like a high-performance race car, you can't just turn the key and expect it to win. You've got to tune it, right? You have to get every setting just perfect. Well, in the world of AI, that whole tuning process, that's all about something called hyperparameters. So let's dive in and see what that's all about.
So it begs the question, right? How do you tell a machine how to learn? I mean, we throw this word learning around all the time, but it's not magic. Machines don't just figure it out on their own in some kind of vacuum. They need instructions. They need a set of rules, a framework to start with. So, yeah, how do we give them that initial push in the right direction?
Well, the answer is you use its control panel. The best way to think about it is like this. Every single AI model has this virtual dashboard covered in dials and switches. And it's the human, the engineer, who has to set all of those dials before the training even kicks off. These are the hyperparameters. And they're super important because they don't control what the machine learns, but they absolutely control how it learns.
All right, let's zoom in on this control panel and really get to grips with what these settings are all about. So if you want the textbook definition, a hyperparameter is a setting that's configured before the training process begins. It's external to the model. What that really means is you, the human, set the value. The model can't learn it from the data. Instead, this setting defines the whole game. It lays out the model's architecture and the very rules for how it's going to learn.
Okay, and this next part is really important to understand. It's super easy to get these two things confused, the settings we choose versus the skills the machine actually learns by itself. So let's break that down.
This chart really lays it all out. On one side, you've got the stuff set by the human. Those are the hyperparameters. They're external, they're set beforehand, and they don't depend on the data you're using. But on the other side, that's what's learned by the machine. Those are the model parameters. They are part of the model itself. They're figured out from the data during training. The analogy I love is this. We, the humans, build the stage. The machine then learns how to act on it. So, why are we spending all this time on this? What's the big deal? Well, because getting these settings right, or wrong, has a huge impact on performance. The stakes here are actually pretty high.
Look, finding the right combination of these settings is a high-stakes game. This whole process, we call it tuning, can take a ton of time, a lot of trial and error, but you just have to do it. Get the tuning right, and you get a fast, accurate model. Get it wrong, you've just wasted a massive amount of time, money, and computing power on something that, frankly, is pretty useless.
Okay, so let's get our hands dirty. Let's take a look at some of the most important dials you'll find on this control panel.
First up, and this one is a real biggie, is the learning rate. Every single time the model gets an answer wrong, it adjusts itself to try and do better next time. The learning rate controls just how big of an adjustment it makes. It's literally the size of the steps it takes as it tries to find the right solution.
And this animation shows you the problem perfectly. The goal is to get that dot to the very bottom of the valley. That's the point of lowest error, the best solution. Now, if your learning rate, your step size, is too small, you're going to be taking these tiny little baby steps. It'll take forever to get there. But if your steps are too big, whoops, you might just leap right over the best spot and end up bouncing around, never finding it at all.
All right, another key dial is the number of epochs. This one's actually pretty simple to get your head around. One epoch is just one complete run-through of the entire training dataset. So you can just think of it as one full practice round for the model.
But here's the catch. More practice isn't always a good thing. It's a classic Goldilocks problem. With too few practice rounds, the model is underfit. It just hasn't learned enough. It's not ready for the test. As you add more epochs, its performance gets better and better, but only up to a point. If you practice for too long, it starts to overfit. It's like it just memorized the answers to the practice questions instead of learning the actual concepts. It gets really good at the training data, but falls apart when it sees something new. The goal is to find that just right zone in the middle.
And of course, there are a bunch of other dials on this panel. You've got batch size, which is basically how many examples the model looks at before it updates itself. There are activation functions, which act like little gatekeepers inside each neuron, deciding whether a signal is important enough to pass on. And then there's a really cool one called dropout. It's a clever trick to stop that overfitting we just talked about. It randomly tells some neurons to just sit out a round of training, which forces the others to learn more robustly.
So, when you look at all these different dials and all these choices, it really brings us back to one central crucial point, the human in the loop, the person who's actually running this machine.
So let's put it all together. What are the big takeaways here? First, hyperparameters are the dials and switches that we humans set before training even begins. Second, they are totally different from the parameters the machine learns for itself. And finally, tuning these dials is absolutely critical. It's part science, sure, but it's also part art. It requires experience and intuition to get it right. And honestly, getting that blend right is what makes the difference between a pretty good AI model and a truly great one.
You know, there's a great quote from Intel on this, and it really hits the nail on the head. They say, hyperparameter exploration is conducted to search and find the optimal hyperparameter configuration. And that word, exploration, is perfect. It's not about knowing the answers up front. It's about a journey, a search, to find the one combination that's going to unlock what your model can really do. And that leaves us with a pretty fascinating question to chew on. We're already building tools that can automatically search for these hyperparameters. So as AI gets better and better at tuning itself, what happens to the human operator? Will that expert who meticulously fine-tunes the machine ever become obsolete? What do you think? It's definitely something to keep an eye on.